SpaceX has emerged as a pioneering force in space exploration, consistently pushing the boundaries of what was once deemed impossible. Founded by Elon Musk in 2002, the company has set its sights on making space travel more accessible and affordable for humanity. With a series of groundbreaking missions, SpaceX has demonstrated its capability to innovate and excel in the highly competitive aerospace industry. One of their most ambitious endeavors is Starship, a fully reusable spacecraft designed to transport humans to Mars and beyond. This spacecraft aims to revolutionize interplanetary travel, making the dream of colonizing other planets a tangible reality. However, the journey to and from space presents formidable challenges, particularly during the perilous phase of atmospheric re-entry. The spacecraft must endure extreme temperatures and immense pressure, which require advanced engineering solutions. SpaceX's commitment to reusability sets it apart from traditional space agencies. By developing rockets and spacecraft that can be reused multiple times, SpaceX aims to significantly reduce the cost of space travel. This approach not only makes space missions more economical but also paves the way for more frequent and sustainable space exploration. While previous spacecraft were designed for single use, often ending up as debris after their missions, SpaceX envisions a future where spacecraft can safely return to Earth and be prepared for multiple missions. This vision is not just about reusability, but also about sustainability. By refurbishing and reusing spacecraft, SpaceX is contributing to a more sustainable approach to space exploration. This groundbreaking approach demands innovative solutions, especially when it comes to withstanding the extreme temperatures generated during atmospheric re-entry. The development of advanced heat shields and other protective technologies is crucial for the success of these missions. As SpaceX continues to push the envelope, the future of space travel looks promising, with the potential to unlock new frontiers and expand our understanding of the universe. As a spacecraft plunges back into Earth's atmosphere at hypersonic speeds, it encounters intense friction with air molecules. This friction generates an enormous amount of heat, enough to incinerate even the most robust materials. This phenomenon, known as aerodynamic heating, poses a significant threat to the structural integrity of the spacecraft and the safety of its occupants. Traditional heat shields, typically composed of ablative materials, are designed to burn away during re-entry, dissipating heat in the process. However, this approach is inherently consumptive, rendering the spacecraft unusable for subsequent missions. SpaceX recognized the need for a reusable heat shield that could withstand multiple re-entry cycles without compromising performance. SpaceX's engineers embarked on a quest to develop a revolutionary heat shield capable of withstanding the inferno of atmospheric re-entry. Their solution, a metallic heat shield, a radical departure from conventional ablative designs. This innovative approach promised not only reusability, but also enhanced durability and reliability. The initial iteration of the metallic heat shield utilized a high-nickel alloy known as Inconel. While Inconel exhibited exceptional heat resistance, it proved to be prohibitively expensive and challenging to manufacture at the scale required for Starship. This led SpaceX to explore alternative materials, eventually settling on a more practical and cost-effective solution: 304L stainless steel. 304L stainless steel, the backbone of Starship. 304L stainless steel, a widely available and affordable material, emerged as the ideal candidate for Starship's metallic heat shield. This material is not only cost-effective but also readily available, making it an excellent choice for large-scale production. SpaceX engineers have spent countless hours testing and refining this material to ensure it meets the rigorous demands of space travel. Its exceptional heat resistance, corrosion resistance, and structural integrity made it a perfect fit for the demanding requirements of spaceflight. The material can withstand the extreme temperatures encountered during re-entry into Earth's atmosphere, ensuring the spacecraft remains intact and operational. Additionally, its resistance to corrosion means it can endure the harsh conditions of space without degrading over time. Moreover, its ease of manufacturing and affordability aligned perfectly with SpaceX's vision of reusable spacecraft. The ability to produce these components efficiently and at a lower cost is crucial for the sustainability of space missions. SpaceX's innovative approach to manufacturing has allowed them to create a robust and reliable heat shield that can be reused multiple times, significantly reducing the cost of space travel. The metallic heat shield is composed of numerous hexagonal tiles, each meticulously crafted from 304L stainless steel. These tiles are designed to fit together perfectly, creating a seamless protective layer. The hexagonal shape is not only aesthetically pleasing, but also provides superior strength and durability. This hexagonal geometry provides inherent strength and rigidity, while allowing for thermal expansion and contraction during re-entry. The ability to expand and contract without compromising the integrity of the heat shield is vital for the safety and success of the mission. This design ensures that the spacecraft can withstand the intense heat and pressure of re-entry without suffering damage. The tiles are designed to interlock seamlessly, creating a continuous protective barrier against the scorching heat of atmospheric friction. This interlocking mechanism ensures that there are no weak points in the heat shield, providing maximum protection for the spacecraft. The innovative design and engineering behind these tiles are a testament to SpaceX's commitment to advancing space technology and making space travel more accessible and affordable. Transpirational cooling, keeping it cool under fire. To further enhance the heat shield's effectiveness, SpaceX incorporated a novel cooling system known as transpirational cooling. This system is a game-changer in the field of aerospace engineering, providing a robust solution to the intense heat generated during re-entry. This ingenious mechanism involves allowing a small amount of coolant, in this case methane, to seep through tiny pores in the heat shield tiles. These pores are meticulously designed to ensure the optimal flow of coolant, maintaining the integrity of the heat shield. As the methane encounters the intense heat of re-entry, it vaporizes, carrying away a significant portion of the thermal energy. This process not only cools the heat shield but also creates a protective barrier against the extreme temperatures. Transpirational cooling offers several advantages over traditional cooling methods. Traditional methods often rely on complex machinery and active cooling systems, which can be prone to failure. Firstly, it is highly efficient as the vaporization of the coolant absorbs a substantial amount of heat. This efficiency is crucial for the safety and success of missions, especially during the critical re-entry phase. Secondly, it is passive, requiring no pumps or complex machinery, thereby enhancing reliability. The simplicity of the system reduces the risk of mechanical failure, which is a significant advantage in the harsh environment of space. Lastly, it utilizes methane, a readily available resource on Mars, further bolstering SpaceX's vision of Martian colonization. By leveraging in-situ resources, SpaceX can reduce the need for carrying large amounts of coolant from Earth, making missions more sustainable and cost-effective.